Hi, my name is Gus. I'm super honored to be here today. What I will be telling you about today is the rise of AI and the revolution that we are dealing with now. What's weird to me is that there was a time when cutting-edge technology was using animals and exchanging information would have happened with a homing pigeon. And what's always struck me as funny is you can't really lose a homing pigeon. I mean, people try all the time, but they keep coming back. So what I would like to tell you today is, as you sit in the chair, the culmination of technology and the kind of data, the capacity for collecting and using data has created a situation that is probably the coolest that it's ever been. And the chance you have now is to be part of a revolution rather than have a revolution happen to you. That's the context within which I'm talking about revolution. An example of what you'll hear about in the media is a past where, let's say, motor cars are introduced, and suddenly the people who drive horses and carriages have to deal with the fact that they have to retrain and start learning how to drive a car. And that's fine. You can have different skills and learn how to drive the car if you were driving a horse and carriage before. But if you're the horse, you are suddenly completely useless. And that stokes a lot of the fear that people deal with these days. They think that suddenly we're going to have a useless class. What I'm going to be presenting to you today is I think people have an infinite ability to create need. And we are all creative people. We have a near infinite ability to solve those problems. So 2 out of 1 million things that we could be talking about in AI is medical. Michalis was just sitting here explaining what they do. And it's pretty weird that I'm a DevOps guy. I fix computer systems. I keep systems like Google.com online, although I never did that. I spent some time at Google Engineering, and it was wonderful. But the building systems now that can make a prediction or to create a number, it used to be pretty hard. It's an area of research, and it is now the area of just making an app like you make an app for your phone. So think about that. 20,000 people die of skin cancer. Why? If you were to internalize that question and go, what if this was your problem to solve? Why? What's the first why? Usually you ask 5 whys. When you're troubleshooting any kind of system, something went wrong or somebody didn't respond, etc. 5 whys. Why? You're naked every day, you take a shower, you put your clothes on. Why don't you have a private doctor looking at your skin? Because to diagnose melanoma is literally looking. That's the skill required. Look at the bloody dot. Second one, whole bunch of people who, like this exact person, has specific needs that really have to be met, otherwise they die. And we have built a society that says, no, you can't get medical help because we know what you need. Why? Why does this happen? This is money. This is cost. So I leapt from probably the best job I've ever had in the best company in the known universe right now, doing the coolest things. I sat next to Google Brain people solving predictive problems for Google Search and for Maps, and I worked with startups every day on the Google Cloud Startup Program. This was one of my customers, and I joined them because instead of companies using AI to increase customer service or to save lives or to increase their own margins and run their business, what I want is AI to be in the hands of every single person. Just like Linux, Android is on your phone, and you can build an app on top of that platform and reach 7 billion people, and they can then exchange, they can maybe exchange data or money, and you can create new markets for things because the platform is open and people can build on top of it. That's what we're doing, and that's why I've joined this team. What we believe in is AI everywhere, advancing humankind. And the way that we do it, I won't spend too much time on it, I just want to share with you where I'm coming from, is to make AI operational. And if you are studying, hands up here, who is in university? Anyone at the back? Anyone in startups? And still in school? All right. And obviously the other class, other, miscellaneous. You'll be learning about this stuff, and ideally, if you're in school right now, people should be touching on this. It's in the realm of slightly hard to understand. I'm going to hopefully demystify the 2 things that, as a normal tech guy, I can now do, and I thought it was only the purview of some of the tippy top, the 1% of the 1% smartest people in the world. There is a revolution, and when you are driving the revolution, this is what you're experiencing. If you look at the media, that's what they're telling you. Don't do that. Don't believe what you see in the media. No offense to anyone, especially Julian before, but if you're not in this field, it's really hard to understand what's actually happening. And it's when people stoke up fears about the robots will take your jobs, I think we're not there, and it'll be a while before we get there. And this is where most people are. Like, they go, am I the horse in the story? So naturally, what do? You go to google.com, you search, and you find out AI is blue. And naturally it's blue. What other color would it be? And AI is a brain with lights coming out of it. Okay. And you think, this is really the crux of what's happening today. If you were to take from 1950 to now, cybernetics and artificial intelligence has been this field of maybe the computer can make a decision, maybe the computer can play chess. And squeeze that down to 1990 to now, we've got applied Bayesian statistics, you have moving probabilities, and you can decide, is it spam, is it not spam? That's machine learning. And a subset of that, true from 2012, 13, 14 onwards, is a combination of availability of data as well as the ability to process that in gaming GPUs from NVIDIA and other places. You have this ability to run deep neural networks. And you can have a set of variables, just like if you're playing Pokemon Go and you're collecting things, your score is moving, that's a variable. Anything in computer science, you're holding variables, you're applying them, this one times that one is the result. It's all just variables and you're applying math to them. What you end up in deep learning is applying this. And you go, what is that? So I now work in deep learning. I can build predictive systems, and I did this for the first time about a year ago. This is a matrix multiply. I did it on Khan Academy. It's great. So you don't even have to have a degree. I studied computer science and applied math, which I gave up because it was boring. I did a business degree, which even that I didn't finish because life was too cool. And I learned what I needed to learn on Khan Academy, which is exactly what you need to build the future. So there's a lot of things that's possible in the world of AI. You can learn about a thing learning to teach itself to play chess and then play against other people and win. There's interesting things happening in the space, but if you were to apply research AI and build something that is immediately going to save lives like brainomics, or to be in the systems that you just heard about, what you'll be doing is two things, understandably simple things, classifications and regressions. Classification, show an apple, you go, it's an apple, or a car, it's a car. And regression is, the best example I have of that is anyone here, parents or family in real estate? Nobody? So if you were to ask her, my mother-in-law is in real estate, and it's always funny to see her, if you ask, what is this house worth? And the house might be on a nice street, but it's kind of dodgy. There's a tree outside, and you see the list of variations. You go, location, tree outside, kind of dodgy. You can fix it with paint. You can fix it up. You can apply. There's so many things, and then she ends up with a number. This house should go on the market for £225,000. That's a regression. You create a number from a fuzzy set. Now, in the past, you had to focus on things that were neatly delineated in tables, in columns, in a spreadsheet, values that were pre-calculated and fit into the box. Well, what if things don't fit neatly into the box? Like, is it a busy street? Is it noisy because there's an airline going across? Or, I mean, you're under aeroplanes. When you're trying to make a decision that people make, there's a whole bunch of decisions or influences in the decision that you can now teach a machine to do. This is probably the nicest way that I've seen to cleanly describe what a convolutional neural network, the thing that does classification on pictures, and the idea that has led to this revolution in deep learning to occur. Every one of those black and white dots is a variable. It holds initialized with random data. And imagine that what you're saying is, if you were to take a 3x3 pixel, or just a very small lens, and you move over the picture left to right, what you'll see is, interesting or not interesting, I don't know, but you see some brown, and then it starts turning white. And if you're a computer, you're assigning numbers. As you click across, click, 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 you're just assigning numbers. And when it turns from brown to white, or from white to the brown of the thing that's lying in that basket, if you get 10,000 samples of this is a dog, this is a cat, this is a dog, this is a cat, you end up with a neural network that can classify dog, cat. You show it an Aston Martin, it can't even say this is a car or a nice car. It's going, bleh. It knows dog and cat. And the second thing that I would like to touch on, because it's fundamental, and this is really all there is about AI, is an activation function. And a nice, not a heuristic, but a way of thinking of an activation function is if you want to go to Bristol, but you know it's cheap to travel if you're 4, your activation function is, of all my friends, if we get 4 people to go, it's a go. Under 4, it's no. So your activation function is if equal or larger than 4, then you're in business, you're doing something, otherwise you're not. Now imagine you apply an activation function to whatever numbers are in those variables and you matrix multiply them together. That you don't even have to do the math by hand, especially not with a pencil. There are libraries for you to do this stuff with. A neuron would activate or not activate, and the signal transmitted up layer by layer, God knows what the computer is seeing, but because you've shown it 10,000 items and say, this is a dog, this is a cat, you can end up with a situation where the model goes, type of fur, the type of texture I've seen, every time I've been told this is a dog, I see what I feel in numbers, it's a dog. And that's pretty freaking weird. That is very, very weird. It's also excruciatingly cool, because as you sit here now, on a platform like the thing that I can now do, and I'm just a DevOps cloud architect guy, I can build a convolutional neural net and say, houses that look like this in a certain neighborhood are $450,000 or whatever they are, and the same house, same street, I mean, this is from an actual data set, the Portland, Oregon house price data set. Pretty dodgy house. Maybe it's in the process of being rebuilt, but that house price is lower. And suddenly you can get a computer to just go drive through a Google Street View and you can start classifying nice areas, bad areas. This is remarkably cool tech that is on the other side of an API. You can build it into an app. You can build a business without knowing how to do any of the research that came before you. This is a freaking cool time to be alive. So really, when it comes down to it, AI is a misnomer, because AI indicates that there's something that's artificial and it's intelligence and it can replace you, but really it's artificial and it's about intelligence. But when you honestly, truly ask those 5 whys, you go all the way back. Guess what this is? This is a Sumerian tablet. It's called Cuneiform, the little cuts and things. It's what we think is the first written language. If there was one that didn't survive, we just don't see it, so we don't know what's the first, but this is what we think is roughly 3000 BC. This is 5,000-year-old texts sent between people. It's probably recording how much corn was sold or Johnny owes me money for buying the farm. And this is just a picture of one of the first Gutenberg Bibles printed in the 1500s. This idea is information that is in me. I learn about melanoma, and I can tell you this is what melanoma looks like, so you can cut it out before you die. But if I die, the information goes away. So if I write it down, it can live on when I die. This idea, even with the printing press and even with the internet, is all about information leaving us and becoming available. We don't have to be there to deliver the information. So up to today, everything that has led to our present technological state has been about getting information out and making it useful. But this is about getting the decision out. So you can make the decision. This is a melanoma. The machine can make the decision. I can sleep. I can be aware. You can decide the house price is X, and it can just suddenly work. You can decide this is what chest cancer looks like, or this is what you should be charging for this item at this time of the day because of people walking past your store. The decision is no longer trapped in the person. It can be let free. So then you come back to the problems that I initially raised with you. Why don't we all have a personal doctor scanning us for melanoma? You can build that. Why is medical so expensive? Well, because doctors train a long time, they are special, but you need one doctor to find out how to make a decision, and then it's for everyone. And that's really the crux of my philosophy, my entire life, and why I'm in this field now. The computer should work, and people should think, and you have the chance to build that doctor so it can work while people are sleeping. So really, your only job is to think, what problem will you attack? Because the tools have been written for you by the people who came before. And what you need is on Khan Academy. It's an incredible website. Please use them. And you can do that. So the future is yours to write. And you can be, am I the horse? You can own this revolution, and you can make something. You can affect the world. Thank you very much.